All right. Coming. Okay, we can start now.
Okay, so yeah, we will start today. We're finally back on the fifth episode of the STEM Girls virtual class on maths. And today we're having a new teacher, yes. So, but you have to make sure that girls, you pay attention, and of course there'll be room for you to drop your questions for answers from the teacher. And please, if there is anything you feel you don't understand as the class proceeds, just raise your hand and the floor will be given to you to interact with your teacher directly on the call. Yeah, so I'll be doing just a brief intro just for you to know to meet a teacher for today before we proceed with the class. We have Mr. Samuel Bukumi. He is a 400 level mathematics student at the Federal University of Oyo, Ekiti. That's Ekiti State. He's passionate about sharing his knowledge with others, particularly younger individuals, and making a positive impact on their lives. His other expertise and passion includes politics, um, researches, tutoring, and data analysis. So, so feel free to interact with him and enjoy the class as you proceed. Yeah. So today, on this episode, we are to learn about algebraic expression. So I think I will leave the forum here for you, sir. Just continue with the class.
Okay, thank you very much.
You're welcome.
Good, good day, everyone. This afternoon, I would like to, take a moment to appreciate the opportunity given to me to be able to work with STEAM girls on the virtual class on mathematics, and the topic we'll be treating today is algebraic expression. Uh, let's go into the introductory part of algebra. Now, an algebraic expressions are the ideas of expressing numbers using letters or alphabet without specifying their actual value. Now, when we are trying to express numbers by using letters or alphabets, the English alphabets, then we can actually call them algebraic expression. Now, these algebraic expression have what is it called? They have components that makes them an algebraic expression. Now, this is just the introductory part. We would soon go fully into the work for today. Now, the basics of algebra taught us how to express an unknown value using letters. Now, you can use any letter to express these unknown values that we are talking about. I told you that we are trying to represent our known values with some letters. Now, these letters we can say letter A, letter B, letter C, letter D, E on to X, Y, Z. In fact, sometimes we use the Greek letters. Now, these letters are called variables. Now, basically, we'll be going into definitions of the definition of algebraic expression, the component of the let me just say the subtopics for today. What algebraic expression is all about, the component of an algebraic expression, the types of algebraic expression, then simplification of algebraic expression, the evaluation. We'll do some examples we saw and would see how far we can go with that. So now on to the next slide, I have the definition of algebraic expression. What is an algebraic expression? Basically, an algebraic expression is a mathematical phrase that combines numbers, variables, and mathematical operation to form a meaningful expression. Now, there's a difference between algebraic expression and algebraic equation. An equation is being equated to something. I don't know if you're getting the equal sign makes it an equation. But for an expression, it is just how would I put it? It's just an expression. It is just there for you to see and solve further if the case, if there is need for you to solve further. Uh, Now we have three main things that makes up an algebraic expression. Number one, we have the variables. Number two, we have the mathematical operations, and number three, we have the numbers. The numbers are also called constants or coefficients. Now let's move on. It can include constant variables, coefficients. I said that, and mathematical operations. Now, what are these mathematical operations? Addition, subtraction, division, multiplication. We have roots. We have squares. We have um what else? We have products. Exactly. Okay, product is the multiplication. So now, expressions are made up of terms. Now, what we mean by term is, let's look at this example. We have 3x squared plus 5x plus 7. That is a very good example of an algebraic expression. Now, the first term in this algebraic expression is 3x squared. That is a term. Combinations of terms using our mathematical operation. That is what we call algebraic expression. 3x squared is a term on its own. 5x is another term. The third term is 7. That means that this algebraic expression has three terms. I don't know if it's getting it. Now, let's move on. These expressions are represented with the help of constants, variables, and coefficients. Now, we'll go majorly in defining what a constant. When you see an algebraic expression, oh, how do I identify the constants? How do I identify the variables? And how do I identify the coefficients? Of course, you know what mathematical operations are. When you see your addition signs, your multiplication sign, your subtraction sign, you should know that those are your mathematical operations. Exactly. Then you have the exponents. The exponent to your exponent raised to the power of, that is powers and then square root. Yes. So let's go into the component of an algebraic expression. A component of an algebraic expression. Number one, we have constants. Those are numbers that don't change value. That should be the next slide. Constants are numbers that do not change value. When you see a constant in your expression, sorry, when you see numbers that don't change value in your expression, then you know that these are constants. Now, variables are letters or symbols representing your unknown values. You know those letters that we talked about. Those are what is it called? Those are what's it called? Variables. Now, variables are letters or symbols representing unknown values. They represent unknown values. We don't know those values. Those values have representation. They stand for something, but we don't know them yet. So those are what we call variables. Then coefficients are the numbers attached to the variables. Coefficients are numbers attached to the variable. Let's look at the first example that I gave: 3x squared plus 5x plus 7. From the That is from the second slide. Can we go to the second slide, please? The second slide.
Okay.
Okay,
Sorry.
yeah,
Here.
thank you. No. But thank you, yes. Now I have 3x squared plus 5x plus 7. The coefficient of x squared in the first term is 3. That is the number that multiplies your unknown value. The unknown value there is your x. That is your variable. Your variable there is your x. So the coefficient of that x, sorry, yes, the coefficient of that x square is 3. Now, for the second term, the coefficient of x is 5. Your coefficient is 5, while your variable is x. And for the last one, automatically, that 7 also has a variable, but the power of that variable is raised to the power of 0. I don't know if you're getting it. There is a particular variable attached to that 7. But then again, the power that variable is raised to is zero, and that is, you know that anything raised to the power of zero, any number you have raised to the power of zero is equal to one. So then one multiply seven to give you seven. Okay, the next one is your mathematical operation, the addition, the subtraction, the multiplication. Now let's go to types of algebraic expression. Types of algebraic expressions. Now, basically, I listed five types of algebraic expression here. But I would make it six. I will briefly explain the sixth. The first one we have is monomial algebraic expression, and this contains single terms expression, just your x or your 2x or your 5x or 7x. When you solve some algebraic expressions, your answers are left in monomial expressions. Now, the binomial expression, sorry, binomial, you know that binomial, and when we're talking about bi in mathematics or in the general real world, that means two. So binomial means two-term expression. When you have two terms coming together to make an expression, that's what we call binomial. So you can have 2x squared plus 7. That is a binomial expression. An example that is here is 2x plus 3, x minus 4. Those are binomial expression. As long as the numbers of terms in that expression is just 2. Now we have trinomial, which is 3 terms expression, and that was the example I gave in the second slide is an example of a trinomial algebraic expression. So here I have x squared plus 2x plus 1. We have 3 terms coming together: x squared, which is one term, 2x, which is another term, and 1, which is the third term. Now we have polynomial. Polynomial are expressions with multiple terms, 4 and above. So 4, 5, 6, 7, 8, 9, 10. If you have um terms, 4 and above terms coming together to form an algebraic expression, we call them polynomial expression. We have rational expression. These are expressions with fraction from our rational numbers. These are expressions with fractions. Examples are 1 over x. That is an example of rational expression. Then 2 over x plus 1. That is an example of rational expression. Now let's go into simplifying algebraic expression. Now we want to go into the main work of expression. We want to see how we can use our mathematical operations with algebraic expression. So now, in simplifying algebraic expression, we have different ways of simplifying algebraic expression. The first one is collecting like terms. What are like terms? Like, I told you that algebraic expressions are made up of terms, coming together. Now, what are like terms? Like terms are terms with the same variable. Terms with the same variable are called like terms. For instance, 2x plus 3x. The variable in 2x is x. The variable in 3x is x. So those two have the same term variable in common. So we can call them like terms. Are you getting it now? If you have 2x squared plus 3x, they are not like terms because the variable in 2x squared is x squared. The variable in 3x is x. So they are not like terms. So now you can combine like terms together. Some people call it collecting the like terms. It can be y. Don't forget that your variable can take any alphabet, any of the English alphabet. It can be A, it can be B. It can be multiplications of variables. If you have 3ab plus 2ab, they are like terms as long as the variables are the same. AB, AB. I don't know if you are getting it. Now, if you have 3ab plus 3cb, they are not like terms because AB is not the same thing as CB. Aha, do you get it? So that is that.
Yes.
Now, the second one is remove parentheses. And now we can remove parentheses using the popular I don't want no, it's not a formula, the popular word phrase that we know, BODMAS. Now for BODMAS, the B there is the bracket. Now when you see an algebraic expression with a lot of mathematical operations, you check first, does this operation have any brackets? If there is a bracket, then solve whatever it is inside that bracket first. So this BODMAS is like a step, a step, a step that guides you on solve questions, how to solve algebraic questions. Now the B stands for brackets, the O stands for off, the D stands for division, M multiplication, A addition, S subtraction. So when you see an algebraic expression and then you have multiplication in that algebraic expression, you have addition in that algebraic expression, you have subtraction in that same algebraic expression, you will consider the multiplication first before you consider the addition, and then you go on to the subtraction. Now we can simplify. The third one here is simplify coefficients. We can simplify the coefficient if need be. If there's a need for you to multiply or divide the coefficient, then you can go ahead and do that. Well, don't worry, we'll solve examples so that you'll be more clear about this. Now, the fourth one is simplify exponents. Now, when you have exponential rules, I believe you've done indices from your syllabus that was given. And now when you have exponential rule, I believe you by now you should know how to go about it. So look at this algebraic expression that we have here: x squared multiplied by x cubed. Now you agree with me that by indices, by borrowing the idea from indices, you can solve this algebraic expression. Now, what indices is telling us, one of the rules of indices is when you have the same variable with different powers, when you have the same variable multiplying each other, and those variables have different power, you add those powers. So now x square, x cube, x is the same variable, but then now they have different powers. 2 is the power for x squared, 3 is the power for x cubed. So now when you multiply them in indices, you add the powers together. So you add 2 plus 2, the answer will be x raised to the power of 5. Okay. So now let's go into um evaluating expression. Evaluating algebraic expression. Yes, evaluating algebraic expression. Now, the first one I have here is substitute value. Yes, there are some algebraic expressions that you will be given. Now, you'll be given the value for your, what is it called, for your variable. So you substitute the value of your given variable into your algebraic expression so that you can use it to evaluate your answer. The second one is follow order of operations, which is the board part that we talked about. Then number 3, simplify the result. If there's no need for you to simplify the result, then you go ahead. Now let us look at examples and let us practice these examples. Now the first one says simplify 2x plus 3x minus 4x. 2x plus 3x minus 4x. So I am okay. Let's go on. Now, 2x plus 3x minus 4x. You would agree with me that we have majorly two mathematical operations there: addition and subtraction. Now, the variables are the same. X are the variables there. Now, to buttress or to buttress what we've done so far, you would agree with me that the coefficient of the first term is 2, the coefficient of the second term is 3, and the coefficient of the third term is -4. So now, if you want to solve this kind of algebraic expression, you can solve them using the order of following the order of operations Now you treat the addition first before you treat the subtraction. 2 plus 3, that is 5. We have 5. Now 5 subtract 4x from your 5x. You have x. Are you with me now? So that is that. Now the second example says evaluate 2x squared plus 3x minus 1 when x is equal to 2. So this second example is an example of substitution method, which is the number one example we have in evaluating algebraic expression. So now what you need to do is whenever you see x in that given equation, you substitute 2 into the algebraic expression. Now you have 2x squared plus 3x minus 1. Now wherever you see x, I said substitute 2 into it, since they told us that our x is strictly 2. Now 2 that's 2 multiplied by 2 raised to the power 2 plus 3 multiplied by 2 minus 1. Now, when you do 2 raised to the power of 2 is 4. So that was 2 multiplied by 4 for your first term plus 3 multiplied by 2 for your second term minus 1, which is your third term. Now, 2 multiplied by 4 is 8. For your first term, you have 8 plus 3 multiplied by 2. 3 multiplied by 2 is 6. So that is 8 plus 6 minus 1. So now you now follow your order of operation, word math. Now addition comes before subtraction. We only have addition and subtraction in this, and addition comes before subtraction. Solve your addition first. 8 plus 6 is equal to 14. Now subtract 1 from it, you're left with 13. So that leaves you with 13 as your answer for the example 2. Now example 3 says simplify 2x plus 1 multiplied by x minus 3. Now, I told you we would use order of operation, which is BODMAS. Now, we have brackets here. The first thing to do is we go through with our bracket, sign. Now, 2x. Now, what you will do here is use the first term in the first algebraic expression to multiply the two terms in the second algebraic expression. We have two algebraic expressions here multiplying each other. The first algebraic expression is 2x plus 1. The second is x minus 3. Now, we use 2x to multiply with two algebraic expressions in the second term. So you multiply 2x with x and negative 3. And you multiply 1 with x and negative 3. So now 2x multiplied by x is 2x squared. Are you with me?
Okay.
2x multiplied
Yes.
by minus 3, which second term in the second algebraic expression is minus 6x. Now you go to plus 1. Plus 1 multiplied by x is x. And plus 1 multiplied by minus 3 is minus 3. So at the end of the day, you now have 2x squared minus 6x plus x minus 3. You have that. Now you can now collect like terms. Are you with me now? So the only like
Yes.
terms that there is negative 6x and positive x. Those are the like terms that are there. Now add those two like terms together. So we have 2x. So now minus 6x plus 2 is minus 5x. It's just like saying you are owing somebody 6 oranges and you have 1 to pay that person back. How many oranges are you owing that person after you paid that one debt of your orange? You are left with 5 debt, 5 oranges that you have to pay back. Are you with me? So now you have
Yes.
for that the 2x squared minus 5x minus 3. Are you with me? So now
Yes.
the last example that we see. I don't know if there's a last example there. Please, can I see the last slide? Thank you. Okay, thank you. Oh, I already solved the solution here. The last slide said evaluate 1 over x plus 1 when x is equal to 2. I believe you also by now you should know that this is also a substitution solution. But then again, do not forget that this kind of algebraic expression is called it's called rational algebraic expression. Do not forget, from our types of algebraic expression, this is a rational algebraic expression. They have
Mm.
fractions. So, but you use substitution method since you are given the value for your x. So now I said that when you are given the value for your x, wherever you see x in the algebraic expression, you substitute the value of your x that you are given into that algebraic expression. Now you have 1 over x plus 1 when your x is equal to 2. So wherever you see x, you put 2. So you have 1 over 2 plus 1. Now you deal with your brackets first, following the Bodman's rule. So 2 plus 1 is equal to 3. And your final answer is 1 over 3. There is no further simplification. If there is, let's say for instance, your fraction, your answer at the end of the day is an improper fraction. Yes, you can then break it down into a mixed fraction. But since you have a proper fraction in this case, that is where you stop solving. Thank you very much for your time and for staying with us to the end of the class. I really do appreciate.
All right, thank you very much. I think I've learned a lot from this. But I would love to ask, um, the I think the last one you made mention of, we have, under the evaluation, we have, yes, we have 2 point something, 2x plus 3. You said minus 1, and the answer was supposed to be, and you gave a first term of 8 plus 6 to be minus 1. I didn't get that part, so I don't know if you can just quickly just run on that.
Okay, the evaluation, that the evaluation you're talking about, where the 8 plus 6 came from is from the second example. Evaluate 2x squared plus 3x minus 1. Are you with me? Are
Okay.
you there? The second example, evaluate 2x squared plus 3x minus 1 when
Okay.
x equal to 2. Sorry, that is not 10. That should be 1.
Okay. Okay.
That is not 10. That should be 1. The zero
One.
should
Okay.
be, yes, exactly. So
All right.
it should be evaluate 2x squared plus 3x minus 1 when
Minus
x
one.
is equal to 2. Now, since you have your x to be equal to 2, since you're given the value of your x, you substitute directly. Are
Okay.
you with me? I don't
Yes.
know, how advanced our girls are. For instance, if you are not given, there's what we call finding the root of an equation, of an algebraic equation also. But I believe
Okay.
that from the syllabus that I received, that is not in the syllabus. So that was why I left it out. Now there are sometimes that the value of your x will not be given, and you'll be asked to evaluate. There's a way to go about that. That is just looking for the roots. Are you with me, ma? But now,
Yes.
because we are giving the value, and because of the stage or the class where our girls are, we will deal with strictly substitution and evaluation. Now, x is equal to 2. When your x is equal to 2, we are asked to evaluate 2x squared plus 3x minus 1. Now, wherever I said it, that wherever you see x, you substitute the value 2 into where x is in your algebraic expression. Now, we
Okay.
have 2x squared. Now, there is x there. That's 2 multiplied by your x squared. Your x is 2. Substitute
Yes.
2 wherever you see x. So you have 2 into bracket 2 squared
Okay.
plus 3x. There is an x there, put 2. So that's plus 3 times 2 minus 1.
Minus one. Okay.
Now, 2 square is simply 2 multiplied by 2, which is 4. So
Four.
that is 2 into bracket 4 plus 3 times 2 is 6
Yes.
minus your third term, which
Minus
is
one.
so 4 times 2 is 8 plus that's 6. Subtract it from 1. And we have our final 8 plus 6 is 14 minus 1. We have 13.
Okay, so why are we not doing away with the bracket in I think we have two bracket 4 plus 6 minus 1. Why not are we not doing away with the bracket here?
That is because I want it to be a step by step guide. Actually, I could have just limited my I could have jumped that step of 2 into brackets 4 plus 6 minus 1. But
Okay.
because of the level of our girls, I left it to be that way so that they would be able to understand why 2 into bracket 2 raised to power 2 is not just equal to 8. They can
Okay.
I want it to be better simplified. Exactly.
All right.
I want to be very, very easy for them to digest and understand.
Okay. All right, thank you very much for that explanation. I believe our girls that are connecting via YouTube that are going to be watching later too will this is going to help them go a long way in. And of course, if we have any questions from them, we'll be forwarding to you so that you can always attend to the question.
Definitely.
The other girl left. I guess some of them that connected left because of network issues. So probably by the time they come back to watch again, we'll be forwarding the recording to them on their platform, the adolescent platform. There they'll be able to have some time, their spare time to listen to the class and send in their questions
There's
for
no
for
problem.
that. Yeah, so we'll be looking forward to getting the assignment for them to
I would definitely forward the assignments.
Yeah, so we've come to the end of the class for today, and we're looking up to having more of you girls connecting. Please do not miss this class. The next class is coming up, and of course, we're going to update you on the next class. So just stay tuned for more updates. And then, if you own a school and you want us to organize or have one of this organize one of the sections with the girls in school, helping them overcome the fear for math, please just let's say call to us through on the number 08062762068. I'll call the number again. Sorry, it's not on the screen, but I just have to call this 08062762068. Or you can email us at stemgirls@agenetwork.org. So stay tuned, girls, for more updates. Yeah, bye. Thank you, sir, for the class.
You're
Do have a
welcome.
do have a beautiful weekend.
And you too. Thank you very much for bringing me